In Act 3, what we're going to do is we're going to discover the proof of the theorem. So here we have Pythagoras, and he's trying to figure out, why is this true? Why is it that a squared plus b squared equals c squared? And so here you're supposed to draw the simple triangle with a sides a, b, and c. So I'll just draw a little triangle here and label the sides, right, a, b, and c. But why is it true? Why the square? Why not a plus b equals c? Why is it that it's a squared plus b squared equal to c squared? Right? And so Pythagoras says, if I just clear my mind, the answer will come to me. But he's haunted, right? He's haunted by the rope stretcher because Pythagoras, told everybody about the Egyptian sacred knowledge, and he's haunted by Hippasus too, because his life was cut short, by his theorem. And so Pythagoras says, ghost, let me be. I have a few years left to solve this puzzle. And so the next part of this activity is for you to solve why a squared plus b squared equals c squared. So on this next page, you notice we have proof. And here's the Pythagorean theorem, a squared plus b squared equals c squared. And the first thing we want to do is try to draw a picture that illustrates why a squared plus b squared could possibly be c squared. And you're given over here some hints, so it says hint 1, under picture, try to create a square out of 4 right triangles in the bag. So here I'm going to create my 4 right triangles. And so to do this, I'm just going to copy this triangle right here. And group them together. Okay, so you were given 4 of these things, and here's 1, here's 2, there's 3, I need 1 more. You're getting 4 of these right triangles, right. And your job was to somehow create a square out of these 4 right triangles. And the way you do this is you simply move them around, and eventually stumble across a configuration that makes a square. Now remember, a square has all sides the same, and so as you push these around, you realize that one way to make a square out of these 4 triangles, if I can get it to work, is so. And here's the 4th, we turn it. Let me put it right there. All right. After you get it, it says copy it to your paper, incorporating the triangle already given. Right? Reading instructions is very important. So I use the triangle already given, and it says make sure you label the sides of the triangles A, B, and C when you draw them. So let's label the sides, because this will help us later on. So A, and that's B, that's C, that's B, that's A, that's C, that's B, that's A. Oops. I messed these up. Wrong spots. Alright, so that's A, that's B, and that's C. Okay. So the next step, right, I get here, and now I'm like, okay, well, I got my square. I'm not really sure, what I'm supposed to do after this, but underneath here it has some algebra. And so, what am I supposed to do with this algebra? Well, let's take a look. Here, over at hint 2, it says, write down underneath algebra, the sum of the area of the parts equals the area of the whole. So let's write this down. Right, the sum of the area of the parts is equal to the area of the whole. Let's see if I can zoom out a little bit more here. All right. So what does that mean? The sum of the area of the parts. Well, on these little triangles, these are actually numbered. So there is a 1, a 2, a 3, and a 4. And so I obviously there's 1, 2, 3, 4 parts, but there's actually a 5th. Right? So the sum of the area of the parts is talking about the area of this triangle, that triangle, this triangle, this triangle, and this inside little square, and it should be equal to the area of the whole. Well, the whole is given by this outside square. Right? If you get stuck, you read hint 3, right, which says write down in terms of A, B, and C, right, the area of 4 triangles plus the area of a little square equals the area of the big square. And it even tells you, and here I guess it's missing, but it tells you, should tell you the area of the triangle is 1/2 the base times the height, and the area of the rectangle is 1/2 the length times the width. And so what I can do here is figure out, the area of the 4 triangles, right? The area of one triangle, here's the base, right? Here's the height, and so it's 1/2 the base times the height, so A times B. That's the area of the first triangle. Plus, I have the area of the second triangle, so 1/2 AB. And I have the area of the third triangle, 1/2 AB. Oops. Let me erase this. So 1/2 AB plus 1/2 AB. And then plus the area of the little square. Well, the little square is right here. Right, and it's plus c squared. Right, and it's equal to the area of the whole. Now here's where I have to do a little bit of thinking. What's the length of this side? Well, it's not A times B. It's just the length of A plus the length of B. And of course the length of this side is also A plus B, and A plus B. So the area of the whole is the length times the width. So A plus B times A plus B, or A plus B squared. Right? That just comes right from hint 3. The area of the 4 triangles, 1/2 AB, 1/2 AB, 1/2 AB plus 1/2 AB, plus the area of the little square, so that's c squared, equals the area of the big square. So A plus B times A plus B. And then hint 4, if you get stuck here, hint 4 tells you what to do next. Right? Combine like terms and multiply things out. Right? So combining like terms, these are like terms. Right? So I have 1/2 AB, and I'm doing it 4 times, so this is going to give me 2 ABs, plus a c squared. And on the right hand side, I want to FOIL things out. Right? FOIL stands for first, outer, inner, last. It's multiplying A plus B times A plus B. And so what I get here is 2AB plus c squared. And I multiply the first 2 terms, A times A, so I get A squared. Right? The outer 2 terms, A times B. The inner terms, B times A, so plus B times A. And the last 2 terms, B times B, so plus B squared. I'm going to combine like terms on here, and so I get 2AB plus a c squared equals A squared plus AB plus BA is the same as 2ABs plus B squared. And if I get stuck, now what do? It says right here, subtract 2AB from both sides. So minus 2AB from both sides. And I get my answer, which is what I was looking for. I have c squared on this side equals A squared plus B squared. So that's the Pythagorean theorem. A squared plus B squared equals c squared. So what this was really a result of is that the fact that a right triangle can be used to create a square. And we know the area of a square is the length times the width. Right, in essence, the Pythagorean theorem is really a product of the fact that a triangle, if you add up all the inside angles, the interior angles, you always get 180 degrees. And finally it says QED, which stands for Quid Erat Demonstratum, which means what was to be shown has been shown.